All right, welcome to the wonderful world of Ionic Nomenclature. Today you are going to need two things if you want to print the PDF off of these notes. It's a bunch of examples, some step-by-step ways of how to do ionic naming and formula writing. You are going to need your periodic table. That's located on the resource tab. If you don't have that one, you're also going to need your resource sheet. So in Chem 1, we use the resource sheet that's on the back of the periodic table. In honors chemistry, we have what we call the gold worksheet, but you're going to have to find basically the chart of polyatomic ions. So when we get to that, I'm going to refer to it's the resource tab for you. Depending on which course you're in, that's what you're going to want to use for that. So a friendly reminder, if you don't have this down, you need to know your charges. We're not going to do valence electrons. You just need to know first column is +1. The second column is 2 plus. Then we go 3 plus. As we skip over here, -1, -2, -3, going through that way, making sure you can find your charges. I'm also going to use this time to show transition metals. So all of these in the middle, I know some students are wondering, well, what charge do they become? If you look really carefully on here, you can see there's actually little numbers down here, even down here for lead and thallium. This is what we mean by transition metals, is sometimes they lose a different amount. So I'm kind of showing just a couple examples. When I look at zinc, zinc is always going to be +2 or 2 plus. It always loses 2 electrons. If you look at silver, silver is always going to lose 1. But when you look at ones like iron, iron can either be 2 plus or 3 plus. What that means is sometimes iron's going to lose 2, but other times it's going to lose 3. So we're going to refer back to this later on. I just like to talk about it early so you start to get an idea of why are there multiple numbers. Cobalt can lose 2 and 3 as we go through there. Here's our rules. For those that like rules and just following them, this is our rules of how to write ionic formulas. We're going to start simple and work our way more complex. Because this is a video, I'm going to go fast through this. But essentially, our ionic formulas always have two names. We are always going to start by writing the cation first. If there's only 2 elements, we write the anion and we change the ending to "ide." This is kind of the only new thing on this. If there's more than 1 or more than 2 elements, we call those polyatomics. We're going to find those either on the back of your periodic table or your resource sheet. So depending on which ones you have there. If it's a transition metal, or if it has multiple charges, we use Roman numerals. So I'll get to that when we go through there. The most common Roman numerals to know are 1 through 6. All right, here goes. A bunch of examples. That's the best way of learning this. First of all, when I look at these, this is what I mean by if it's polyatomic or not. Is there more than 2 elements? So right now I see 1 Na, 1 Br, 1 Mg, 2 Fs. But what I mean by that is there 3 or more? Well, there's only 2. So this is how easy naming is. We find Na on our periodic table, sodium. And then I get used to checking, does sodium have more than 1 charge? Does it have multiple charges? And I see sodium's always +1, so I'm done. Then we got to name Br. Br is bromine, so we take the root of it. Bromine becomes bromide, sodium bromide. Done. It's that simple. We move on to the next one. Mg is magnesium. Again, magnesium is always +2. Then I find F. F is fluorine. Fluorine becomes fluoride. I'm going to go a little faster through here, but you kind of see the pattern. K is potassium. I check. Potassium is always 1 plus. N would become nitrogen. We take the beginning of it. Nitrogen becomes nitride. So as we do these, it just takes more practice. You get to know some of these a little better. There's lithium. H becomes hydride. It's not hydrogenide, but it takes practice, it takes time. Those wondering where the numbers, we don't worry about that when it comes to ionic. We just go barium. Barium's always 2 plus. Got it, check. Phosphorus becomes phosphide. And then the last one, aluminum. Iodine becomes iodide. So that's entry level. That's as easy as it gets. What we're going to eventually get to is this, Cu. Cu is copper. And when I look at copper, copper has multiple charges. So I would leave a blank there for Roman numerals. Chloride. That's coming a little later. All right. I use the phrase of more than two, it's the back for you. If we need to change it to more than two, it's resource for you. That works. But this is what I mean by polyatomic. Now we have 3 elements. 1, 2, 3. 3 elements. Well, that one's actually 4, but more than 2. So here's where we use our resource. The first part doesn't change. What's my cation? Sr is strontium. And now it's like, where's Waldo? But more fun because it's chemistry. You would need to find what is PO4 on your resource sheet. And when you find PO4, and this is why spelling matters and you got to slow down, PO4 is called phosphate. Note there is a phosphite, that is PO3. So look carefully for these. You might have to slow down. If I do the next one, K, that is potassium. All right, I named that. Now I find all of that on your resource sheet. So C2H3O2 is called acetate. Notice as we've been naming these, there's pretty much a first name and a last name. That's how this goes. There is one tricky one, so I always kind of point this one out. If it starts in NH4, that is also a polyatomic. You're going to find that on your resource sheet. That is ammonium. It is one of the few positive polyatomics. So we named NH4. Now that doesn't change. F becomes fluoride. If I go quickly through this, okay, we got an Mg. Mg is magnesium. Okay, I named Mg. Now I find SO4 on the back, and that is sulfate. So I just point out on the resource sheet, most of them will end in ate or ite. Al is aluminum. CO3 you would find on there, and that's carbonate. I know I'm going fast, but you can pause if you need to, go back, make sure you're finding these. All right, some students that like math find this really easy. Some students not a big fan of this. So to start, I'm gonna go slow through this, and then eventually for those that are at math, you start to do this in your head. The whole goal of writing formulas from names is they have to have a total charge of 0. So we did this with ionic bonding. If charges cancel out, we just write the symbols. Otherwise, we use subscripts to balance out the charges. And then as we get to polyatomics, we're going to use parentheses. Roman numerals will tell you what charge each ion is. In my class, I do a song and dance, check charges. Makes it more fun. But this is where we did the dots. And we would go zoom. We're skipping this now and just looking up ions. So we would say, okay, Na is 1 plus, Cl is 1 minus. Does that add up to 0? Yep, done. Down here, I'm going to skip just to go a little faster. Mg, I would just look up the charge, is 2 plus. F is 1 minus. Does that add up to 0? It does not. We need to add another F. So this final formula would be MgF2. So I just wanted to show a few examples. Basically, now we're working backwards. Okay, check charges. We look up sodium. Sodium is 1 plus. We look up fluoride. F is 1 minus. Plus 1 minus 1 adds up to 0. We get NaF. This is my final answer. Note there are no charges in my final answer. Don't skip steps and make this take longer. Another quick one, we got magnesium. That's 2 plus. Sulfide is 2 minus. Again, this adds up to 0. Plus 2 minus 2. So my final answer would be MgS. But more often than not, they're not that easy. It would be something more like this. Find potassium. Potassium is 1 plus. O is 2 minus. If I have 1 plus and 2 minus, this does not add up to 0. So we can add to either one to make 0. We need another K. So what's my final count? Again, we start with the cation. There would be 2 Ks and 1 O. Skip down here and then we'll do the hardest as it gets. Here's aluminum. Aluminum is 3 plus. Chloride is 1 minus. Again, right now that adds up to plus 2, not 0. Now it's plus 1. Now it's 0. So what's my final answer? Al, Cl. And how many chloride ions did I need? I need 3 of them. So what that means is there's 1 Al, 3 chloride stuck to it. For those who like math, this is as hard as it gets. Calcium is 2 plus. Nitride is nitrogen, and it's 3 minus. What do 2 and 3 go into? They both go into 6. So to get plus 6, remember we multiply. We would need 3 CAs. To get minus 6, plus 6 here, minus 6 there, that adds up to 0. We would need 2 Ns. So that would be my final answer. So checking charges. Check charges. Eventually we get really good at these and you do them in your head, but that's what I mean by checking charges. Don't skip steps right away. You might need to write it out. Now with polyatomics, it's the exact same rules, but now we have to find them on your resource sheet. So magnesium, Mg2 plus, carbonate, if it ends in 8, you find it on your resource sheet. Carbonate is CO3, and this whole blob is carbonate. We can never change what that is, but the charges work the same way. If I have a plus 2 and a minus 2, they just cancel out. We get MgCO3. That's my answer. Let's skip to a different one. We got calcium. Calcium is 2 plus. Hydroxide is a trickier one to find. That's 1 minus. But these rules don't change. They still have to add up to 0. So what do I need? I need another OH. So note the parentheses here. I'm saying I need 1 Ca. I need 2 of all of this. I can't change what that is. That's like one day waking up and just changing your DNA. It doesn't work that way. So we add our OH. We go parentheses 2. So there's 2 of those. Let's skip to lithium nitrate. That's a fast one. Lithium's plus 1. Nitrate is 1 minus. If I got a plus 1 and a 1 minus, those just cancel out. So my final answer is LiNO3. So see how there's no charges in my final answer. As hard as it gets, strontium, 2 plus. Phosphate is PO4, 3 minus. And again, the closest they go into is 6. So how many strontiums do I need? I'm going to need 3 SRs. How many PO4s am I going to need? I need 2. And again, I can't change this. So I write down the PO4. It's not PO4, it's not phosphate. And I use parentheses. I need 2 of those. That's really as hard as it gets. The only other thing to go through, how do we use Roman numerals? Well, because iron or lead or cobalt have lots of different choices, the Roman numerals are just telling you which iron is it. So when we look at this one, the rules don't change. We still got to check charges. Now we're telling you, not that we need 3 irons, that this one is 3 plus. If I look over here, we're telling you, not that we need 2 leads, but lead is +2 or 2 plus. Cobalt is 3 plus. That's how the Roman numerals work. So if I do this one, we got iron and we got chloride. It's the same checking charges rules. How do I get that to add up to 0? -1, -1. Here's FeCl3. Done. Acetate. Ooh, the hot mess of C2H3O2. 1-. Just like this problem, we need how many? 3 of those. So I would need 1 cobalt. I write all this down. That's what acetate is. And I use parentheses. I need 3 of those. So as hard as it gets, working backwards. This is where some students love this, some hate it. Mg. All right, I know that one. That's magnesium. Does magnesium have multiple charges? No, magnesium's always +2. We're done. Check. Now I would look this up. You can see a lot of these repeat. This is phosphate. That one first, and then we're going to kick it up a notch to over here. I'm going to show this 2 different ways. Pb is lead, but this is where we need Roman numerals. Lead has more than 1 charge. So we leave a blank. All right, lead. I'm going to have to say which lead it is. S would be sulfur. Sulfur becomes sulfide. And now here's how I do it, because I like math. I work backwards. I know sulfur is 2-. So my total charge is 2-. That means my lead would have to be 2 plus, because 2 minus 2 is 0. This should be lead 2 sulfide. Let me do another one. Here's Ni. Ni is nickel. Nickel can be +2 or +3, so it needs Roman numerals. F stands for fluoride. All right, if I work backwards, I know F is always -1. That means my total negative is -3. That means my total positive has to be +3. So for this example, nickel has to be Roman numeral 3. If I skip down to this one, Fe is iron. Iron can be multiple charges, so I leave that. What's O? Oxygen becomes oxide. If I work backwards on this, here's where math gets a little trickier. Oxygen is 2-. That means this is -6, because 2 multiplied by 3 is -6. To add up to 0, this needs to be +6. Well, 6 divided by 2, that means iron needs to be 3 plus. So the Roman numeral has to match the charge. It's not how many are there. That's a common mistake students make. We go back on this one. Sn is tin. Tin has multiple charges. OH I would find on my resource sheet is hydroxide. Again, I work backwards. This is -1. That means my total negative charge is -2. That means my positive charge has to be +2. So this is tin 2. I know I went through this fast. There will be lots of examples in your upcoming classes to go through this. I hope everyone's having a great day. Buckle up and drive safe, Rebels.